Hello, and welcome to my proprietary website, Resume Tie. This is Abhishek here, and this year, as you can see, is my second draft of this website. Started working on it about a year ago in fall of 2014. I am a student at Loyola University Chicago, and I have been working on basically a master's in IT and a business degree in entrepreneurship. And so I decided I would like to pursue the two degrees by meshing my classes together, sort of, and creating one major project that touches upon several of my business classes as well as my um, technological classes. And so in the fall, I worked mostly on the back end stuff, classes that involve back end, such as working with C Sharp.net, programming in my Visual Studio.net environment, and several front end languages as well. There's use of JSON, AJAX, jQuery, etc. in this website. And I then in the following semester I worked more upon the user interface, kind of made this more appealing, went beyond the functionality, so made it prettier, I guess. And so I'm going to go ahead and demonstrate what this website does, and in this video in particular, I'm going to explain it from a large-scale website perspective in terms of a distributed systems architecture, how that would work exactly for a website like this. Um, so I've already created an account for my friend George here, and so you can say hello, George. Just gonna go back really quickly. Please do note that right now it's running off of my laptop, my local host here, so it is a bit slow. So essentially what you do is you go ahead and upload your resume document. So I went ahead and already uploaded one because write times take a long time off of my computer. And that is actually something that's very important to note in distributed systems architecture is that when you are writing into a database versus reading, it often takes longer. In fact, I researched a little bit into this and I found out that write versus read speeds are often 3 to 1. And so, we want to make sure, like, since the thing is, read files are usually read from cache and write files reach out to the disk. And another reason why it takes longer is because it may rewrite several times over multiple servers, especially if this becomes, over time, a largely distributed system with a growing user base. We would need to consider that as well. Um, so, regardless, the writes are always slower than reads. Um, so, Upon testing the image reads and writes at any point, it is better understood what database should be used. So specifically, I looked at some benchmarked databases, and I found that databases with a focus on greater concurrent writes and reads, it may actually be better to move away from MySQL and lean towards Versant JPA or Versant Object Database, or even MongoDB to better fulfill our goal of low latency. Um, Now, low latency, of course, means nothing but faster retrieval times. So right now, since we're just starting this as a, no, we haven't even started yet. I'm planning to launch this hopefully in August or so. It would start off, of course, as a new venture, and so the database would be relatively small. So MySQL for now is okay, but if there is hopefully a growing user base over time, then definitely we could switch over to these other databases. But it's not needed immediately upon launch. All right, so before I move to the next step, I would like to explain, or actually, I'll go ahead and go to the next step. So now that we uploaded the resume, we're gonna map links. Okay. So this is the page that makes this entire service very unique. So essentially, what a user is able to do here is highlight portions of the resume. So for example, let's say I have my education. So I would highlight that, or I have my work experience, let's say. And then I can link this to secondary documents or external web links. So for example, I can link this to, so I worked here, you can see I worked at Mars Global, candy company, everyone's favorite. So we can go ahead and type in, let's say Mars.com. So, and then I go ahead and click on save. So now this has been saved, this mapping here, I saved it. So this correlates exactly to here. Now when someone visits this document, and then they can also upload an external document. So let's say I choose to do this instead. I can upload a document. So let's say I select my education, and I would like to upload my transcript. So I'd go ahead, and it would take a while right now to just have it right into this database, so I'm just going to explain this. And also I still need to fully fix this function. This part isn't working 100% yet just yet. But I would essentially upload a document, and you would then go ahead and a user would now view your resume. So I'm going to now go to manage my resume. So I already saved one of my links, and when I point to it, it jumps to it, by the way. So let me go back to manage. Should come in a second. Alright, so I already uploaded my document. Here we're going to view my document here. So here it is, the document I just uploaded for George. Well, it has my name, but pretend it's for George right now. And we have properties, so we can mark it as either public or private. If you make it public, then anyone can view it. If you make it private, you would essentially enter a passcode, and then only people that have that passcode can view this page. So we're just gonna keep it public. We're not gonna mess with this right now. So head back. Alright, and then map links is what the page we just saw. And then search data, this is the very last step, we'll come back to that later. And then email. So now we go really quickly to email just to demonstrate this. So it's going to open up my email client, Mozilla Thunderbird, which I have on here. Open in a second. Alright, so here it opened up my email. And just says, oh, George Drew has sent you a link to the resume on Resume Tie. And you take, so as of now it's just this ugly hyperlink, but eventually my plan is to make it resumetie.com/George, and then you would take that, your own customized hyperlink, and you would send that out to anyone that you would like to visit this employer, etc., whoever. So I'm going to go ahead and copy this. All right, they would receive this, enter it into their browser as hit enter. Right, it's loading, and so by the way, that line that came up right there, that was demonstrating that it has received the request and that it is now processing it from the front end. Anyways, so now oh, and by the way, that's called a queue, something I mentioned in my distributed documentation as well for more information on that. So here's my document, and now I'm going to go over and hover over this. So as you can see, my box has been drawn as soon as I hover on it. One little fix I still do need to make on this is make sure these boxes they are already there on top of the document. Otherwise, it's kind of hard to just like go over and find it. But anyways, so they would go over it, and when they click on it, it would go to the hyperlink Mars.com. Right now, I have to just go into the localhost/Mars.com, but eventually what's going to do is the basic idea is you would click on it and it would go to that. Similarly, if you click on it, it would open up, if let's say you link your education to a transcript, or let's say a certification, you link it to an image of your certification, it would, you would click, I as an external user, as an employer or a friend, whoever is viewing, would click that box, and it would pop up open the external document or certificate, whatever. You have freedom to decide what you want to upload. So it would open that up here, and I could view it in that way as well. So basically, my idea here is to create an interactive resume, and that's my unique idea for this. So essentially, what the trick to doing this is, from the back end, the technology is I'm using open source code for actually converting the document that I uploaded into, as you can see, an image here. So this entire thing is an image. This allows me to use my other JSON code to allow users to draw, as you saw in my map links, draw coordinates around certain parts of the resume, and then map their secondary links and hyperlinks, and then documents, images, etc., and then make it user friendly and interactive. Um, so essentially, from a large scale website standpoint, this would be storing several images like a website such as Flickr or even Facebook, which stores millions of websites a day. Sorry, million of images a day. This would, over time as the user base grows, many images would be stored onto the server, and therefore calling for more, greater manageability, which is nothing but just how easy it is to operate. It would make it harder to manage more servers at a time without failure under, discovered exceptions, and diagnosing and problems and making modifications should stay easy as the user base grows. Of course, another consideration for this is cost. We would, from the business end, it is important to understand that as more users enter, more space is needed, and since this is storing not just the documents but also the images, we need to take into consideration that just like any large-scale website like Flickr or Facebook, we have our need for server space is going to grow pretty fast if more and more resumes are being added onto the servers. So, and then of course, aside from the hardware and software physical costs, we would have the we would have to look into deploying and maintaining the system costs, further time, operational time, training time, etc. Um, so yes, another thing is reliability is a major issue that we should look into. So reliability basically that builds user trust. So a user should expect that any request for data will consistently return the same data requested. So when I pull up this page, I should be getting my highlighted mappings as soon as I save them. It should be saved upon the server. And so I should expect it to reveal the new data immediately. Another one is availability. That's just a general concept to understand, is that even a few minutes of downtime of this website result in frustration for the users and potentially even loss of revenue. So distributed systems, they focus on ensuring that the website is always available even if the server is down, and it should be a requirement, both from a technological and business standpoint in that light, to uphold high availability. And then, so for this, the servers that we have should mirror one another basically, so that if one fails, we just call over to the other one. And the data should be replicated across multiple servers, so that if one server is down, another server, can take over right away. And we can disperse this geographically as well. This By doing that, performance can be taken care of. So often, geographic. If we disperse our service towards geographically, so that a user or whoever is viewing that resume um, is reading from a server that is closest to him or her, they may be able to the page may load faster for them. So this would lead to greater user retention, and then ultimately lead to higher search engine rankings, and even eventually from a business standpoint, once again, high revenue. Um, so yeah, for websites nowadays, this is increasingly important for sure. Fast response time and low latency, fast retrieval. So these are some of the main key principles of web distributed design that we have to keep in mind when making the distributed website, a large-scale distributed system architecture like this. Now, I think one of the most important principle is scalability, and this factor refers to the effort that is required in growing a distributed system. So, in a large-scale website like this, size will undoubtedly, as I already mentioned, with so many images coming in, it will play a large role in how many servers are needed. And so, accommodating the rapidly growing databases, um, not only do we need to take size into accountability, but also the effort that goes into it. So what I mean by that is there are several parameters, such as like we would need to take into account the not just the increasing storage capacity, but maybe even the additional traffic that may start coming in. You know, if there's a greater user base, more people will be using the website. The server will have to take into account more people visiting the website. Um, and then maybe even if there are greater amounts of writes, more uploads, we would have to take that into account as well. So concurrent concurrent writes and reads. Uh, this is all considered under the topic of scalability in distributed systems. Alright, so I think the next thing I would like to point out, so I'm going to return to my new edit page. Um, So I did mention low latency. I think I would also like to mention. Oh, right. Okay. So I just mentioned scalability. So now I'm going to go ahead and take a deeper dive into how scalable system designs actually work. So the functionality of resume tie, the best way to approach it is to divide it into disparate services so that it better resembles service-oriented architecture, SOA, which is largely the way most of these other big sites divide their services into. So what that, in simplest terms, what that means is the different functionalities of this website should be taken as different services. So for example, this properties functionality should be taken as one service. Map links, one service. Search data, email. These are all single functionalities that all are disparate, distinct services that should be considered for in our architecture. And more in depth, and specifically in our map links, we should understand that our reads and writes. So when our external user is reading, that is one service that they're able to pull up an image from our database, and then when another user is writing their image into the server, that is yet again another functionality, and therefore should be thought of as a separate service. So the reason I decouple these functions like that is because these complementary services may, in this manner, illustrate a more clear relationship between what the overall underlying service is in the front end environment. And so this makes manageability one of the principles I mentioned earlier. It makes that easier. Um, and also, if we have a problem, if there's any roadblock, for example, if let's say there's an issue with adding links, right? Something people are complaining that this is taking too much time, or there just seems to be some issue with that. We can understand, is it because of the external uploads, or is it because of upload documents? If we treat each of these functionalities as separate services, so we can better manage any issues, and this makes manageability easier. So this, uh, so yeah, okay. So now I'm going to go ahead and talk about a scenario where we fast forward into a future where, once again, hopefully resume tie is under heavy use, and from this perspective of system-oriented architecture, we can assume that both writing resume images to the server and reading those same resume images are taking place heavily, right? So now it can be better understood why longer writes are impacting the time versus why longer reads may be happening. That's another example. So the reason is because we know the two functions are competing for the same resource, the same resume images that correspond to the secondary document resources, and we can understand is which one is it, the write or read. I mean, more often than not, as I already mentioned in the beginning, it would be writes that are most likely taking up more time, just because we would probably be rewriting our documents over multiple servers. Um, you may even throw in an SSD to speed it up, but database writes will usually be slower than reads. Um, and so that's where, if there is heavy usage, then Versant JPA or Versant object databases could kick in to, better accommodate this sort of need rather than MySQL. Um, as mentioned earlier, Another reason as to why these services should be split up into complementary is so that we can solve problems. And if this isn't done, services not actually involved in the issue may get intermingled inadvertently, and that's something we want to avoid because we may make a distributed system decision that is, something that is not really even correlating to what the problem is, and so, we may not even solve the problem then. Um, Next, I would like to discuss, uh, I'd say, next important issue is why we, I mean, probably one of the most obvious and something we can't avoid in distributed architecture is redundancy, really. How does redundancy play a role in a large-scale website like this? So, I mean, of course, if data is not copied onto a backup server, you're going to lose that file, you're going to lose that data if you lose that server. So that would, of course, discourage users from using the website and make it less reliable. And not only does that apply to data, but services as well. So all these services of uploading your resume and reading, pulling up the resume files. These are uh, these are all uh, important parts that. Sorry, I just lost my train of thought. What was I saying? Oh, right. Yeah. So we need to take into account that services are also essential in spreading them across several servers, so that if one fails, the whole service does not go down. So the service should still be available, and so that's why we should copy the functional services of resume tie over multiple servers. So basically, doing this is termed as failover, providing points of multiple points of failover, in which the system may rely on. And this in the long run goal of this is just to make the architecture more resilient. Um, one architecture I looked into in terms of redundancy for service redundancy was the shared nothing architecture. This was interesting because this is where each node operates independently and no central server manages the state or coordinates the activities for the other nodes in the distributed system. So there's no central brain. It's like each server is managing its own state. And I believe this would be the best for resume tie because in terms of scalability, just because new nodes may be added without any special rules or condition. So for a large scale website, this probably might be the best way. Um, I think the next most important topic to deal with scaling over time is um load balancers. So, as already mentioned, let's say a catastrophic event happens and destroys an entire data center. We would, we would want to have redundant copies on geographically disparate pieces of hardware, so that that's why it's if a volcano comes or something, we have hardware on different land so that we can as if nothing ever happened. Um, and so the prime way to deal with this would be load balancers, which would essentially distribute the load across a set of nodes that are responsible for the service request. So this is beneficial because simultaneous connections are routed to one of the request nodes, single request node, which allows the system to scale the service to more requests by simply adding more nodes. And so the biggest challenge with this, however, is maintaining user session-specific data. So let's say a user is logged in and updates the coordinates, here, and upon updating his coordinates, he goes to another page, right? Now my solution to this is, if he went to now here, I went ahead and updated the coordinates like this, and then I went to a different page. I didn't save anything yet, so I'll explain why I have the save button. So I go to a different page. Let me go to my manage page now. So should upload in a second. So I went here, now I'm going to return to my page. I return. So I left the page, returned, and now, as you can see, the change did not persist, obviously, because I did not hit the save button. That makes it obvious. But let's say I did not have that there. Some sites may attempt to keep their whatever coordinates that were highlighted here. They could just leave that there, and that would be considered user session-specific data. The reason I don't say that right away, and I require the user to save it, is because I would like the user to be responsible for saving, being accountable for saving their changes. And the reason is because, see now, if the user is routed to a different node upon revisiting the page, there may be inconsistencies between the changes made and what they will view upon the next visit. So like when they came back to this page, they may be routed through another node, different from the one that they were originally routed through. So that would cause inconsistencies, and we would not know if their changes were saved in the first place or not. So, liability standpoint, you know, so th- or sorry, not fail because there would not necessarily be a backup, right? So that's why I require them to save it because there's no backup of the mapping they just made if they do not. It's the best probably. If a user uploads and links a secondary document to a part of the resume page they highlight, the code should be, that mapping should be saved immediately. Um, and then I think the best solution is, as I just mentioned, is hitting the button. So that way the user, if one change is made, they they may leave the edit page and come back via a separate node. So that's the big advantage. So they made their change here. I went ahead, clicked on save here. After I made my mapping here, I hit save, and then I went to manage, and I came back. The thing is, I could have came back through a different node. If I have a large scale distributed, of course, right now I'm just doing it off my laptop. But if I have a large scale um, architecture, I could come back through a different node, and this will still be intact. And my user session specific data is still there. So I guess I accommodate this point in distributed systems by using load balancers. And another thing is that you can further take advantage of them moving those nodes, which may be poor at handling requests. However, for something like that, you would have to monitor extensively because let's say you do remove a node, uh, the nodes that are already there will now have to take the extra load that the removed nodes were previously taking for them. Okay, next I would like to talk about why also we scale in the first place. So let's say we have a data file that is just too large. Let's say let's say someone enters a resume image which is more than one page, multiple pages of someone who's very accomplished has 4 to 5 pages of resume, and for some reason it's just obnoxiously large and cannot fit. Then we have the option to scale either horizontally or vertically, and so hence capacity may be added in to other servers. So horizontal means we're horizontal. We're literally adding more servers. That's what is most often understood as. But it should also be understood as capacity vertically as well. So we just adding drives or accommodating the entire data set um, into a, to make the server big. Considering doing this for premium users who I could offer greater storage space to, who may upload more resume images onto the servers, they can get backing up the hardware, backing up the data, backing up the services, etc. Uh, so overall, I will utilize horizontal and vertical scaling for both data and load. And then for data specifically, the website on geographic boundaries, whoever is closest to whichever server. All right. Seems I'm cutting close on time here. Okay. So now I would like to quickly close it again. Okay. So I just talked a little bit about touch upon why it's important to do that from a perspective of reading data. The next thing is we should also take into account writing faster. So as I already mentioned, one solution was the other databases such as Percent. Um, and this is important, being able to quickly and successfully retain users, we should be able to quickly write as well, you know. And so to do this, it might not necessarily be an issue in the beginning because the traffic and load is less in the beginning. But as we elicit a larger user base, more complex system writes will eventually call for unwanted higher latency in the system. And so one of the solutions that is built into for Resume is to build asynchrony into the system. So oftentimes you will find a distributed system, smaller system, distributed systems may be synchronous systems, where each client requests a task to be served remotely, individually. So one at each client is requesting their own task from wherever they are. Okay, and so in a small system, yeah, this is okay, but then the server may get overloaded by this with more requests than it can handle, and this wouldn't be good because then users are forced to wait more, and as I mentioned, there's longer retrieval times then. So you can't expect that simply adding servers will address this full load problem. Even with load balancer in effect, it would be difficult to enforce a fair and even distribution of the task to maximize the distributed system's performance. So essentially, the best solution is uh, for the server is to handle requests. So what we would do is, oh, sorry, one second. Still working or no? Still. Why is it slowing down? Okay, yes. Okay, yeah. So essentially, what is happening is um, a major solution to this is to use queues, which is asynchronous uh, versus the synchronous task way of handling the task. And so, what happens here is that let's say a user queries something, so a reader or write, then a queue will occur. So it's literally a task comes in, is added to the queue, and then is then run by the server as capacity becomes available. So this could represent any task, as I mentioned, a write or a read, or and even more complex activities such as generating thumbnail preview, etc. And by using a queue, the user will no longer have to wait for the results. Rather, they will receive acknowledgement that the request was received, and that um, they'll get a front end acknowledgement that which I use on my with my percentage bars. You must have just saw when I hit back and front. Should come up again. Let me hit manage. The system is slowing down for some reason. But yeah, if you saw, there's a yellow bar that flew across and went 0 to 100%. So it shows that it's acknowledged and that it is now being fully processed as server space frees up. Right now, it seems my local host is completely jammed. Anyways, so unlike in a synchronous system where request and reply cannot be differentiated, an asynchronous queue would allow the user to perform other tasks while waiting for the request to be completed. So these queues, they're helpful because it can prevent from embarrassing client-side errors because we can go ahead and retry requests until the queue is working, and something in the backend goes haywire, we can retry the request. So it's another distributed system solution. So yeah, in the end, we're going to have a more robust distributed system by not exposing any service outages to the users up front. So these are mostly many of the main principles I take into account. The main technology being, once again, the document and image, and therefore that's how we work with uploading, reading, and writing images, basically, rather than just documents, as well as secondary hyperlinks and secondary documents. So thank you for listening, and if you have any questions, please feel free to contact me.